In this lecture, we'll discuss about flip-flop conversion, necessity of flip-flop conversion. That is, why we doing conversion, and we will discuss the flip-flop conversion process also, steps. Okay. First, we'll see the necessity. I will give you one example. Suppose I want to design serial adder. I want one full adder and one D flip-flop. I have full adder but I don't have D flip-flop, I have T flip-flop. So in this case, what is the options? What are the options? I have to go and buy D flip-flop. That is one option. And another option is, if I able to convert or utilize that T flip-flop into as a D flip-flop, then I no need to buy. This is the second option. Okay. So the flip-flop conversion is about how to utilize the existed flip-flop by making or converting it into required flip-flop. Okay, that's the intention. So we can do nearly 12 types of conversions. We can do T to D and vice versa, T to SR and vice versa, T to JK and vice versa. Then D to SR and vice versa, D to JK and vice versa, SR into JK and vice versa. Total 12 conversions we can do. Okay. Given or existed flip-flop, two names, required or desired flip-flop. Okay. So now we'll see conversion process. There are 3 steps. In the first step, we have to mix the characteristic table of required flip-flop and excitation table of given flip-flop. We have to mix both as one table. So here Q1 and Q1 plus 1, present state and next state will be common to both characteristic table and excitation table. Suppose if Q1 and Q1 plus 1, any one or both contain X, in this case the given flip-flop data inputs become X. That is the first step. Now second step, we have to determine the simplified equations for data inputs of given flip-flop. Okay, by assuming required flip-flop data inputs and present state as K-map variables. Okay. Then in the third step, we have to draw the given flip-flop symbol because we have that only, that flip-flop only, na? So we have to take the given flip-flop symbol and we have to make it as required flip-flop from the simplified K-map equations. Okay. So in this given flip-flop symbol, the outputs are present state and its complement. Okay. So in further lectures, I will take 2 examples. I will show each step how to do. Okay. In this lecture, we will discuss the conversion process of T into D flip-flop, T to D conversion. Okay. So this is the step 1. I told in the previous lecture, in the first step, we have to take the characteristic table of required flip-flop and the excitation table of given flip-flop. So here given flip-flop is T and the required is D. So I taken D flip-flop characteristic table and T flip-flop excitation table and I mix it together. Okay. So this D Q1 n plus 1 become the characteristic table of D. This Q1 n plus 1 and T, these will become excitation table of T. So here present state and next state will be common to both. Okay, this is the step 1. Coming to step 2, I told we have to simplify this data input value of a given flip-flop T. Okay, by assuming required flip-flop data input and present state as K-map variables. Okay, so D and Q1 are K-map variables, so we need 2 variable K-map and we have to determine the simplified equation for T. Okay, that we have to do. See, this is the simplified equation for T. What is the T value? D XR Qn. It means D bar Qn plus D Qn bar. Okay, this is the second step. Now in the third step, what we have to do? We have to take the given flip-flop symbol. What is the given flip-flop T? It will contain T clog Qn Qn bar. I told we have to assume present state and its bar as outputs of given flip-flop. Okay. Then what is this T value? I got D Qn XR of D and Qn. So I take an XR gate. I given D here and I given Qn here. Okay. Then it will become as D flip-flop. This is the flip-flop conversion process of T into D. In this lecture, we will see the flip-flop conversion process of JK to SR. Okay, this is the step 1. I told we have to take a characteristic table of required flip-flop and excitation table of given flip-flop. SR is the required, JK is the given. So SR given n plus 1, this part will become characteristic table of SR. Qn plus 1 Jk will become the excitation table of Jk. So here present state and next state will be common. One thing you have to observe here, whenever x came in present state or next state or both, this data input values of given flip-flop become x. See here x, 0, x. Then we have to blindly write xx in the data inputs. Here also 1x. Any one or both is x, then we have to blindly write x in the data inputs of given flip-flop. That you have to remember. Okay. Then second step, we have to determine the simplified equation for this given flip-flop data inputs for J and K by assuming required flip-flop data inputs and present state as K-map variables. So S or Qn become K-map variables, so we need 3 variable K-map to determine J and to determine K. Okay, na? Now J will become S, K will become R. Okay. Then in the third step, we have to take the given flip-flop symbol. What is the given flip-flop? JK. And we have to make it into as required flip-flop by using these simplified equations. So what is the J value? S. What is the K value? R. If I connect like that, it will become as what flip-flop? SR flip-flop. I taken JK, I made it into SR flip-flop. Okay, this is the conversion process. This how to get characteristic table, excitation table, I explained in the flip-flops lectures. Okay, go through that.